Hello students, welcome to EduSim. So this video we are going to discuss bipartiteness of a graph using BFS, or else you can say to check the bipartiteness of a graph using Q, because Q data structure is using in BFS. So before watching this video, I request you can watch the previous lecture video, where you'll get the idea about BFS. Also to get the idea about time complexity, how we are getting it. You can check the previous video, which is introduction or introductory video of graph. Let us start. So here I'll simply write such steps which will help you how the bipartiteness or checking of bipartiteness is working. So I'm just writing the bipartiteness. If you want to check the bipartiteness of a graph, first step is I request, like I have seen many videos, many content provided in the internet as well as the books I have read, that I found all are starting with -1 0, some naming conventions like 0 1. No need to go for it. The previous video where we discuss about coloring effect dot v dot color, u dot color, the coloring effect which we done, so that you're using as the coloring of your, like, two colors we are using to differentiate the bipartiteness. Before that, we should say what is bipartiteness. Bipartiteness we need to differentiate the number of vertices in two different groups. Okay, as per the definition, bipartite is basically we are finding similar group of nodes, where it will be helpful in neural network and for artificial intelligence and machine learning. So bipartiteness basically it helps you to differentiate a group of or subset of two different vertices, a group of two different vertices we are using. Like I think all of you have done in a school level. Okay, like match. Suppose A is there, B is there, certain elements there and certain elements are there. You need to match. So here you need to match. Okay, that matching is all about, like, here is a subset, here is a subset, but they both are not connected. If between there, suppose 1 is there, 2, 3 and 4, here 5, 6, 7, 8 is there, so A and B, they should not be connected. Only the connections between the two different sets. Okay, the one element from one set will be connected to the another element present in the different set, but they should not be connected among each other. This is why the bipartiteness is important for us to understand, and this is how it will run through the data structure named uh, Q. Okay, the approach we are using is BFS, breadth first search. Next step on what we have to do first, we have to check whether a cycle is there or not in a graph. Okay, is there any cycle or not? First we have to check. Clear? Step 2, if a cycle is existing, then find which find how many, that could be better, how many vertices are helping to create the cycle. Clear? If if even number of vertices are creating the cycle. Okay, if even number of vertices are creating cycle, then bipartite is possible, otherwise not possible. Clear? Bipartite first step is we have to check whether cycle is existing or not. If cycle is existing, second step what we have to do, we have to check even number of nodes or vertices are responsible for creating the cycle or not. If odd number of uh, you can say the vertices creating the cycle, you have to stop there. Next step 3, we have to color the source. Either you can start with the blue black, red green, you can say white gray, anything. As for the book it is white gray, it is written already, or you can say black gray, white black, anything could be possible. Clear? So you can color any color. So I'm just taking it here red and green, that could be better. So I'm just writing start color. We can say start widget the vertex by changing the color to red. रेड ब्लू भी कभी कभार चलता है, but I am here using the red and green. Okay, visit the vertex by changing the color to red, then next next then connected vertices of the previously visited vertex, then connected vertices of previously visited vertex will be colored as red blue भी कर सकते हो. I'm just writing blue. I was thinking for green, think this as blue. Okay, not an issue. So widget the vertex by changing the first when you are visiting, you go for it red. Next you just change it blue. Do not go for 0 1 minus. This is not exactly the way to represent the color. A 0 1 is not to be written. This is purely wrong concept. I have seen everywhere. Okay. Some are like they what how they are saying this anonymously, I don't know, but actually to differentiate it, we are using some uh, two values, because we are actually using two different sets. We separating it two different subsets. Okay, that is why we are using it. But 0 1 is not to be done. This is not the way actually. Okay, because as per the book which will follow, this is clearly being mentioned. V dot color, U dot color. Why not you are taking that one? This is correct, no? So visit the vertex by changing the color as red first, then color blue, then continue until all vertices have visited and colored. Clear? So until all vertices have colored and visited, you just run it. Okay. Then last, what you have to do in step 4, separate two different groups. Separate the vertices in two different subgroups based on the color. Okay, this is the steps that I have written. So first step is we have to we have to check whether a cycle or not. If there is cycle, then we have to check even number of vertices are creating a cycle or not. Then what you have to do is step 3, you have to check when we start with that, we have to check the color as red, next as blue. Okay, we have to do it until we have visited and colored all the vertices. Step 4 says we have to separate the vertices in two different subgroups or groups based on their colors. Okay, now we will be discussing with the example or the proper example I'm just taking. Okay, example. With an odd cycle we will create, with an even cycle also we will create. Okay, okay, first we start from the chain. As for this, we say we should color as red. Color as red now. We started now. The color as red. Clear? Already it is red, so I changed to some deep color. Okay. So now I changed it as red. Next immediate will be changed as blue as per this. Uh, okay. You may color it by this. Okay, not an issue. But I just changed it. Okay. I just changed it. So that's why uh, okay, so next it is said to be the immediate to the previously visited color will be changed. So as we changed it, so we make this as red. Once we change this as red, so next immediate has to be visited is D. So then to replace that we have to color this as blue. Okay, so once it is done, so what we have to write is we have to write uh, the the elements or the vertices one by one, like A and C, they are not connected as we have seen in the previous videos, the previous example like here which we have taken. So we have to basically differentiate this one B, then D. We have to change as per the color. Now you check, this one is your red. Okay, so I'm just writing this as your red. Now you can check this as your blue. Okay, this is how you have to first differentiate, and you keep the a's at it as it is. The a's which you have, right, A to B should be there, B to C should be there. Clear na? A to B, B to C, and then C to D. Here no such directions or no such edges you will find between A to C and B to D. So here we can say bipartiteness we checked, and this is the bipartite graph of the above graph which we have taken. Clear? Next example we will be focusing on the cycle, where you can say A is there, okay, B is connected, now C is there, here D is there, E, last there is F. Okay, I told you whether there is cycle or not. Here though it's bidirectional. If you don't know how to find cycle or not, you please go to the introductory video. There you'll get it. Okay. So definitely, though it's a bidirectional, you can start from B, C, then the same point you are actually approaching again. So in this way, what you have to see is exactly we can reach using a cycle. But as we have written on the step 2, we have written if even number of nodes or vertices is creating a cycle, then we can find the bipartiteness. So here this is 1, 2, 3, 4. The vertices involved in a cycle, they should be even. Then only we can go for it. Otherwise, if odd, we should stop. Or you can say if even length, if the length is even while creating the cycle, even length cycle, then we can find. Odd length we cannot find. Okay. So length is, you can say, the number of vertices are counting as the responsible who are responsible for creating the cycle, either even, then we can find it. Now you can check as for the color. I'm just changing that color now. Okay, but I'm just highlighting it by changing the color. So here I'm just highlighting it. Okay, first one is red, so it's red, so it's actually matching. So I think I should change the color of the red as yellow. uh, Maybe it is not visible now. Okay, the color suppose. Okay, now it's visible. A was there before. Okay, so now I'll highlight the next one. Is first we started from A. Once we started from A, the starting vertex will be considered as red, next will be considered as blue, the next to it is blue, so I kept this as blue. Okay, so the immediate connected will be considered as the previous color, which is a red. Okay, so here C and D we colored. Okay, I'm just writing that C and D, here C, here D. Okay, now the next immediate will be colored as blue. So if you start from D, next immediate will be E. C, if you start, the next immediate will be E. So here you find this is the color which we have done. Next to this E is your F, which is, we should be colored as a red. Clear? So no problem that we found till now. So we can say it's F now. Okay. So once we start with the checking of it, so we have to first write the nodes one side as for the color, the order. The last step is this one. D, C, D also you can change because no such order actually we are following, and B with the E. Okay. Now I'm just changing the color for it. The red, one group is red, another group is blue. Okay. Next, what will be there? We have to match A to B. There is an age. We will keep that age. A to others are not an age there behind. Then B to C, there is an age. B to D, again there is an age. Then C to D, B to others are not there. Then C to E, C to E, D to E also an age existing. Then E to F. This is how we can say it's a bipartite. Once we divide, no such problem we found. The same group doesn't have any age connected to it. If they will be connected, so definitely we can say it's not a bipartite graph. So we can say it's a bipartite graph. Okay. So it's a bipartite graph of the above graph. The above graph is suppose G. So bipartite graph, you can say it's a G under B. Clear? So it's a bipartite graph. Then example 3, like we will check whether it violates our rule or not. So A is there, the same example with a new node I'll add where it is C, then D I have written there, E, here only F is written. So G. Clear? In that case, what we have to do? Clear? I have to check, is there any cycle existing? Yes, of course there is a cycle existing. Then how many nodes or vertices are there to make a cycle? So we have seen 1, 2, 3, 4, 5. 5 is odd number of vertices responsible for creating it, though it's a cycle. So we said as for the rule it is not being possible for us, but still we start. We start for for the just to start it, just to check it, I started from A. You can start from B, not an issue. You can start from B, you can start from C. Though we started from A, so that's why I'm just starting from A now. Okay, so from A if I start, I colored it red. The immediate will be colored as blue. Okay, now I'm changing the color as blue. Once it is done, once it is done, so the next immediate will be colored as red. Okay, so C, I change the color C as a red. Okay, here I colored the F as C and F as red. I change the color now C and F. Now as for the C, the color will be blue. Okay, as for the F, here the color is blue. You can change whichever is uh, possible for you. If I start from C, the next color will be blue. So here the highlight I am going to do is, there is blue. Okay, so I changed now. Next, as per this, we will make this as blue, but as per this it should be red. Why? Because the previous color here for this blue, we can say the previous one was red, that's why we should color it as blue. Clear? We should color this as blue, but as per this we should color this as a red. So confusion occurs. Though confusion occurs, you can say definitely there is a problem while finding the uh, you can say while finding the bipartiteness of a graph. You can think like, we suppose not you know finding whether it's blue or red. Suppose think this is blue, not an issue, you go for it. Suppose bipartiteness is not possible, we are just checking it now. Okay, if this is blue, so definitely the coming one is red. Okay, not an issue. So this is red for us. For a timing, we are actually checking it. Okay, next you can write this as your G. Okay, so name it now. A, C, F, G, here B, D, E. Okay, I said there should not be A's between the group. Okay, think this is your red, this is your blue, think this is your blue. Okay, A to B connection is there, B to C, clear. B to F is also connection, not an issue. C to D is correct. F to E, F2 is correct. D2 is there, D2 is there. So here this is not possible for bipartiteness. While checking, so you have to go for checking of this. So D2E, if you are just making it, if you are changing the color as red also, in that case you are keeping red here, which is E. E to F is there, connection is there. So definitely, so while creating it, so we should have to avoid, because of the responsibility of the nodes. If the responsible nodes are even nodes, then only we can run the bipartiteness. Otherwise we can simply say bipartiteness is not possible. Bipartite graph is not possible or impossible in this graph, because of odd length cycle or odd vertices, odd number of vertices responsible for making the cycle. That is why we are avoiding it and we say it's not possible. Okay, so here in this way, I think you have understood how the bipartiteness could be possible. So the time complexity here, if we're finding to know the bipartiteness of a graph, the time complexity is big of p plus e or n plus e due to adjacent or adjacency list. If you're using adjacency matrix, that could be v square. And like this, we have already studied this one. For space complexity, if you are using adjacency matrix, that could be v square or n square. Okay, this is how we have completed. I hope the bipartiteness could be easy for you to understand. And next, based on the queries, we are going to arrange the question answer sessions of different videos. Thank you for watching. Have a good day.